Hey guys, welcome back to another geometry video. Last week we left off on this slide talking about perpendicular lines. So before we move on to new topics, we'll just go over this theorem on the top. And it states that two non-vertical lines are perpendicular if and only if the slope of one is the negative reciprocal of the other. So using this theorem, we're going to go through a problem on the next slide having to do with perpendicular lines. It asks us to show that triangle ABC is a right triangle, and it tells us the vertices. It says that A is at 1, 1, B is at 4, 3, and C is at 2, 6. So how should we go about this problem? It asks to show that ABC is a right triangle, and what we just learned was a theorem on perpendicular lines. And perpendicular lines create right angles. So we're trying to find perpendicular lines in this triangle. And to do that, we can find the slopes of each side and see if any of them are opposite reciprocals of another one. So first we can find the slope of side AB, and remember M stands for slope, and if you remember that the equation for slope is the change in y values over the change in x values. So that's what we're doing. We're taking the y coordinates and subtracting them from each other, and then dividing it by the change in the x coordinates. And we're left with 2/3 for the slope of side AB, and the slope of side BC is going to be 3 minus 6 over 4 minus 2, and that gives us a -3/2. And finally, the slope of the last side, AC, is equal to 1 minus 6 over 1 minus 2, which simplifies to -5/1, or just -5. So out of these three slopes that we came up with, if we find a pair of negative reciprocals, that means that two of the sides are perpendicular. And if two sides are perpendicular, that means that it creates a right angle, therefore making the triangle a right triangle. So if we take a look at these two, 2/3 and -3/2, we can see that these are actually negative reciprocals. So the triangle would look something like this, with this side being AB and this side being BC. Because they're perpendicular, they're going to create a right triangle, and then this side would be AC. This is another problem based on perpendicular lines, but in addition to this, we have to worry about bisectors. And if lines bisect or segments bisect, we learn that they're split into two congruent parts. Okay, so it asks us to prove that side AB and CD bisect each other and are perpendicular to each other if the endpoints are A -3, 5, B 5, 1, C -2, -3, and D 4, 9. So the first thing we can do is graph this on a coordinate plane. So if we have a plane, A is at -3, 5, right here. D is at 4, 9, over here. B is at 5, 1 over here. And C is at -2, -3. So we're left with these segments. And next we can find the midpoints of both segments, because if we find midpoints that are the same, that means that they're bisecting each other. If they have the same midpoint, that means both segments are split into two congruent parts. And last lesson we learned how to find the midpoint of something. So let's try to find the midpoint of segment AB. The midpoint of segment AB is equal to the average of the x coordinates and the average of the y coordinates. So here, all I did was take the x coordinates of A and B, which you can see A has an x coordinate of -3 and B has an x coordinate of 5, and we took the average of that, so we added them together and divided by 2, and then we did the same thing for the y coordinates. And if we simplify this, we get the midpoint of the segment, which is 1, 3. If we do the same thing for CD, segment CD, we take the average of the x coordinates, -2 + 4 over 2, comma, the y coordinates, and this actually gives us the same thing. So what we just proved was that AB and CD bisect each other. They have the same midpoint over here, 1, 3, and having the same midpoint means that both segments are split into two congruent parts, so they're bisectors of each other. And now we move on to proving that they're perpendicular to each other. So how do we do this? It's like we did in the last problem. We have to find out if the slopes of these segments are negative reciprocals. So to find the slope of AB, change in y over change in x, we get that the slope is -1/2. For the slope of segment CD, the change in y over the change in x gives us 12/6 or 2. And these two slopes are opposite reciprocals of each other. So because we found this out, we can say that these segments are also perpendicular. So what we did up here, these first two lines, we proved that they're bisectors of each other, and the bottom two lines we proved that they are perpendicular to each other. Before we move on to parallel lines, there's just one theorem I want to go over about altitudes of triangles. So the theorem is that altitudes of a triangle are concurrent. What this means is that they intersect at one point. That's what concurrent means. So if we have a triangle, say, on a coordinate plane that looks something like this, with a point on the x-axis and on the right side of the x-axis if we remember what altitudes are, they're segments stemming from vertices to the opposite side, creating a right angle. So the altitude from this point here, I'll use a different color. The altitude from A, 0 would stretch to side BC and create a right angle. The altitude from C, 0 would stretch to AB and create a right angle. And then B, vertice B, would have an altitude coming down here, creating a right angle at the origin. And what this theorem says is that the altitudes of a triangle are concurrent, meaning that they meet at one point. And you can see in this diagram that they do meet at one point. And that's basically what this theorem is trying to say. So now we are going to move on to parallel lines. So what is a parallel line? Parallel lines are coplanar lines that have no points in common, or have all points in common. So what this means is that parallel lines, these two lines are parallel because no matter how far they stretch, they'll never intersect each other. And if they have all points in common, they'd basically be overlapping lines. And down here, two distinct coplanar lines are either parallel or intersecting. So over here, this pair is parallel, and down here, this pair is intersecting. So every pair of lines is either parallel or intersecting. So what's a transversal? A transversal is a line that intersects two other coplanar lines. In two different points. So here on the right side, this diagram has two lines, M and L, and this line splitting both of them at two different points is the transversal. So with the transversal comes many different angles that are created on these lines M and L. So interior angles, if we were to identify them on this diagram, they would be the angles 3, 4, 5, and 6. These angles are part of a ray between line L and line M. So 3, 4, 5, and 6 interior angles inside line M and L, in between them. Exterior angles are the opposite, so they're 1, 2, 7, and 8 in this diagram. They're on the exterior or the outside of lines M and L. Alternate exterior angles are on the opposite sides of the transversal and do not have a common vertex. So what this means is that so one of the pairs is 1 and 8. 1 and 8. This is a pair of alternate exterior angles. They are on opposite sides of the transversal. This angle is on the left of the transversal, and this angle is on the right. And also, they do not have a common vertex. Another pair would be 2 and 7. Same side interior angles do not have a common vertex, and they are on the same side of the transversal. So 3 and 5 would be a good example. They are on the interior, in between M and L, and they are on the same side of the transversal, on the left side in this case. Another pair would be 4 and 6. Corresponding angles are a pair of angles, one exterior and one interior, that are on the same side of the transversal. So good examples of these are 1 and 5, 2 and 6, 3 and 7, and 4 and 8. So corresponding angles are on the same side of the transversal and include one exterior and one interior angle. So 1 is an exterior angle on the left side of the transversal, and 5 is an interior angle on the left side of the transversal, so they're corresponding. Vertical angles, these pairs include 1 and 4, 2 and 3, 5 and 8, and 6 and 7. Vertical angles share the same vertex, but are on the opposite side of it. So 1 and 4 have the same vertex or same point, but they're on opposite sides. And vertical angles are always congruent to each other. So angle 1 and angle 4 are congruent, 2 and 3 are congruent, 5 and 8 are congruent, and 6 and 7 are congruent. One theorem having to do with transversals is that if two coplanar lines are cut by a transversal, that so that the alternate interior angles are congruent, then the two lines are parallel. Okay, and with this theorem, we can use it to prove this right here. So if we're given that line AB and CD are cut by a transversal EF at points E and F, and that angle 1 and angle 2 are congruent, prove that line AB is parallel to line CD. So to prove this theorem, we can use an indirect proof. So what that means is we can make an assumption and then contradict the assumption to prove this theorem. So what we can do is assume that instead of the lines being parallel, that they're not parallel. So we can say that AB is not parallel to CD. And this is an assumption that we're making in order to prove this theorem. As you can see, the assumption is the complete opposite of the proof. So we are going to disprove this assumption in order to prove this over here. And of course, we know what we're given. So the first step was to assume. The second step was to use what we're given. After that, we can state that line AB and line CD intersect at some point P. Assuming that they're not parallel, they have to intersect. So AB and CD intersect at point P. And that's part of the assumption. It's just building off of what we set at first. And if these lines intersect, then the angles 1 and 2 would not be congruent, but we're given that they're congruent. So we know that the measure of angle 1 is congruent to the measure of angle 2. And this is from what we're given. So it completely contradicts our assumption, because if the lines did intersect, then the angles would not be congruent. So from this contradiction, we know that the lines are actually parallel. That's going to be it for today, and we'll definitely continue next week on these parallel lines, and I'll see you then.